Have you ever looked up at the night sky and dreamed of seeing something magical? Imagine ribbons of green and pink light dancing above your head. This is the Aurora Borealis, the famous northern lights, usually reserved for the far north. But what if I told you this celestial dance could visit Spain in 2025? It sounds like science fiction, but the universe is full of surprises. The sun, our star, is entering a period of intense activity, sending more energy and particles into space. This cosmic weather could push the aurora farther south than ever before, maybe even to the Iberian Peninsula. Scientists know the sun follows an 11-year cycle, and we're approaching its peak, the solar maximum. During this time, solar flares and storms become more frequent, making rare auroras possible in unexpected places. The question isn't if the aurora can travel south, but how far it will go during this powerful peak. Our journey begins at the heart of our solar system, exploring how the sun's power shapes our skies. Join me as we discover if Spain's night sky could soon glow with an otherworldly light. Let's find out if 2025 will be the year Spain gets its own celestial fiesta. So, what exactly are these lights? The Northern Lights, or Aurora Borealis, are a natural light show caused by the sun's particles colliding with our atmosphere. When these charged particles hit gases like oxygen and nitrogen, they create glowing colors: green, red, pink, and purple. Oxygen high in the atmosphere glows green. Even higher, it can glow red. Nitrogen closer to the ground adds pink and purple. Each color reveals which part of the atmosphere is being touched by the sun's energy. These particles are part of the solar wind, a constant stream from the sun. Earth's magnetic field usually shields us, but some particles slip through at the poles. There, they enter the atmosphere and create the auroras we see. The Northern Lights are a direct, visible connection between our planet and our star. They remind us we're living inside the sun's extended atmosphere. This light show is a beautiful result of our relationship with the sun. It's a dynamic process, changing with the sun's mood and our sky's makeup. The aurora is the sun reaching out, painting our night sky. It's a universal phenomenon, happening right above our heads. To understand the aurora, we must understand its source: the sun. Our sun is a seething ball of hot gas, driven by magnetic energy. Its magnetic field twists and tangles, sometimes snapping and releasing huge bursts of energy, solar flares. These flares are often followed by coronal mass ejections, or CMEs, massive clouds of solar plasma hurled into space. When a CME is aimed at Earth, it's like a cosmic hurricane heading our way. It takes 1 to 3 days for these particles to reach us. When they arrive, they slam into Earth's magnetic field, triggering geomagnetic storms. These storms inject energy and particles into our magnetosphere, supercharging the aurora. Normal solar wind creates everyday auroras near the poles, but a CME can create super auroras, pushing the lights far beyond their usual boundaries. The sun's fiery breath, its most violent outbursts, drives these rare, spectacular events. The more active the sun, the more CMEs, and the greater the chance for a global light show. That's why solar activity matters for aurora hunters. If the sun's particles are everywhere, why don't we see auroras all over the planet? The answer: Earth's magnetic field. Our planet acts like a giant bar magnet, with field lines looping from pole to pole. This magnetic shield deflects most solar wind, but it's open at the poles, like a funnel. Charged particles are guided down these field lines into the atmosphere near the poles. That's why auroras form in a ring, called the auroral oval, around the polar regions. The oval's size and position change with solar wind strength. Calm solar wind keeps the oval near the poles. Strong wind pushes it farther out. That's why you usually have to travel north or south to see the lights overhead. The southern hemisphere has its own aurora, the Aurora Australis, but it's harder to see from land. The poles are where the sun's energy finds its entrance to our world. It's a beautiful interaction between the sun and Earth's protective, yet leaky, magnetic field. Sometimes the aurora travels south, during strong geomagnetic storms. These storms, triggered by powerful CMEs, overload Earth's magnetic shield. The auroral ovals expand, pushing toward the equator. The stronger the storm, the farther south the lights reach. In a major storm, countries like Spain, at about 40° north, could see the aurora. For this to happen, we need a powerful, Earth-directed CME with the right magnetic orientation. If all conditions align, the resulting storm can push the aurora far enough south to be visible from Spain. These events are rare, but history proves they're possible. The Carrington event of 1859 brought auroras as far south as Cuba and Hawaii. Telegraphs failed, sparks flew, showing the sun's power. The aurora isn't just a polar phenomenon, it's global, waiting for the right cosmic storm. When the sun unleashes its full power, the lights can reach almost anywhere. Spain could be next. The key to seeing the aurora in Spain is a powerful solar storm, and that requires an active sun. The sun follows an 11-year cycle, from quiet minimum to stormy maximum. Right now, we're heading into the peak of solar cycle 25, the solar maximum. During this time, sunspots multiply, and solar flares and CMEs become frequent. More sunspots mean more chances for powerful, Earth-directed CMEs. Scientists at NASA and NOAA have been surprised by the sun's recent activity. It's more intense than expected. The peak is now forecast for late 2024 to mid-2025. This is great news for aurora hunters. A stronger solar maximum means more strong storms. Already, recent storms have brought auroras to places like northern Italy and Arizona. As we approach the peak, the odds of a major event increase. The sun is waking up, and the stage is set for rare auroras at lower latitudes. 2025 could be the best chance in years for Spain to see the lights. The cosmic show is about to begin. So, what are the real chances for Spain in 2025? It's unlikely, but more possible than in over a decade. Seeing the aurora from Spain requires a perfect storm, a G4, severe, or G5, extreme, geomagnetic event. These storms are rare, happening only a few times per solar cycle. But with an active solar maximum, the odds are better than ever. If a G5 storm like the Carrington event occurs, the aurora would almost certainly be visible from Spain. Even a strong G4 could bring the lights to the country's north. Several G4 storms have already brought auroras close to Spain's latitude. Experts are cautiously optimistic. The period from late 2024 through 2025 offers the highest probability. The more CMEs, the higher the chance one will hit us just right. It's like a cosmic lottery. The solar maximum is our ticket. There's no guarantee, but for the first time in years, it's a real possibility. All we can do is watch, wait, and be ready. The universe might just offer Spain a rare, magical night. If a massive solar storm hits, your location in Spain matters. Rule 1, go north. Regions like Galicia, Asturias, Cantabria, and the Basque Country offer the best views. The Pyrenees, especially at high altitudes, are also excellent. Rule 2, escape city lights. Light pollution will wash out the faint aurora glow. Head to national parks or remote areas with a clear view north. The best time is during the darkest months, September to March. Nights around the equinoxes are especially good, but any clear, dark night during a storm could work. The most important factor is the timing of the storm, not the season. The best viewing hours are around local midnight, between 10 p.m. and 2 a.m. Be patient. Auroras can appear, fade, and return. If a major storm is forecast, plan to spend several hours outside, watching the northern horizon. Your dedication could be rewarded with the sight of a lifetime. Spain's night sky could surprise you. A major solar storm is coming. You're in northern Spain, far from city lights. What now? Don't expect curtains of light overhead. Look for a faint, colorless glow on the northern horizon. It may look like distant city lights, but it's different, a whitish or grayish arc. Use your smartphone or camera. Long exposure photos will reveal hidden colors, green, red, or pink. Red pillars mean a strong, low-latitude aurora. To boost your chances, follow space weather alerts from NOAA or Aurora Forecast apps. If a G4 or G5 storm is predicted, drop everything and head north. The possibility of seeing the aurora in Spain is a rare cosmic invitation. Will it happen? Only the sun knows. But the chance is real. So look up, be curious, and be ready. The universe may soon put on a show for Spain.